is expected value of x squared minus this, right? And this is the same as this. Right? This guy is the same thing as this, like what I said the other time. Now, right now, expected value into x minus 1 plus, we've gotten that to be that, and here, right? I only need to figure this guy out. Need to figure that guy out. Now, I want to figure this guy out now. Right? For this random variable. Which is q raised to the power x minus 1. Oh, sorry. Okay. Now, if I bring out p, I'm going to have this. Right? I'm going to have this. Now, if I have this, I can introduce q and this. Because you know why? I want to use the idea of second derivative. Now, introducing this and this, okay, so that this is going to be we can rewrite that as this. Or let this guy join this guy. And we got this. Right? Now, I want to focus on this guy. Okay? Take a look at this. If I have this guy, okay, the q is this. Right? If I differentiate again, right? Look at this. And look at this guy. And this guy is here. Right? I'm going to put the second derivative now. I want to believe you're looking at it, right? Okay, now, let me tell you this. This course is theory of statistics. In theory of statistics, you need to have understanding of mathematics. Okay, calculus and algebra. Now, expectation of this equal PQ S start from 1 to infinity. Then I'm going to write the square this. I'm going to write that. This guy now is replacing this guy. Okay? Now, if that is what I have right now, so expectation into x minus 1 equal PQ. Okay? This guy is going to come out. This squared, this q squared, then I'm going to have this. You remember the other time? That guy is this. And you consider sum to infinity, right? That guy is that. So if that guy is that, I'm going to have this. The square, the q squared into q1 minus q. It means I have to differentiate this guy twice. Okay? Using the quotient rule. Now, so PQ So I'm going to have 1 minus q for the first time. Okay, differentiating that minus that, this divided by this squared up to this moment. The only thing I did, now I'm going to put this. Okay, when I differentiate this, I have this. So this is going to go down to first derivative. I need to simplify this, then differentiating that again. Okay. So if some of you, if you have lost touch with calculus, with algebra, I will advise you set up an appointment with me. You meet me during my office hour because you need that knowledge in this course. That's what I call theory of statistics. Okay. Now, the Q, when you simplify this, that's going to be like 1 minus Q plus Q divided by 1 minus Q squared. So this cancel that. So I can rewrite this PQ D dq to be 1 minus Q raised to power minus 2. Right? See, this is going to be 1 over that. So I want to differentiate this guy now. This is a composite function in mathematics. Okay, now finally, I'm going to differentiate that guy. Let me look at my time. Oh, 52. Yeah, nice one, because I plan to derive for 3 distribution. This is the third one, right? Bernoulli binomial geometric. Yeah, that was my plan for today. Now, expectation into x minus 1 PQ. Now I want to differentiate this guy. Okay, minus 2. Then inside, negative 1. Write everything. 1 minus Q raised to power negative 3. Okay, so here now, it's going to be 2PQ. Okay, this guy here is the same thing as P raised to power minus 3. Don't forget 1 minus Q equal to P, right? So this is 2. Combine this and this. 2P raised to power this. So it's going to be 2Q over P squared. Right? Now, which is this guy. Right? Now, finally, the variance of S, don't forget, is this. Right? So which is going to be this guy, 2Q over P squared plus 1 over P minus 1 over P squared. Now here, you are back at 5th grade work now. 5th grade, right? P squared, right? P squared, 2Q, P, right? 1, right? Look at that. Okay, so here, so 2Q, I want to get the numerator in terms of P. What is P? 1 minus Q, right? 1 minus Q minus 1 divided by P squared. What happened? 2Q minus that. Okay, that is it. That's how to prove. Now, today, we've proved mean and variance of Bernoulli, mean and variance